Hi everyone, this is Mr. Zikri. In this episode, we are going to study about Bernoulli's principle. Before explaining about Bernoulli's principle, I'd like to tell you that this Bernoulli's principle is hold responsibility for some phenomena in our daily life. First of all, it governs the principle of how aeroplane fly. And then there's some also daily phenomena that actually following this principle. This principle is actually relating between pressure of a fluid and the velocity of it. So here, pressure of a fluid decreases with increasing speed. What does this mean? That if there is a fluid flowing inside a pipe, when the speed is increasing, so the pressure at that point is decreasing. But vice versa, if the speed is decreasing, the pressure is on that place is increasing. So I'm going to show you an example here. If you hold two pieces of paper in front of your face, let's say there is no wind flowing through the paper or around it. So we know that the pressure at 3 points here, left, in the middle, and on the right, has the same pressure because there is nothing difference between them in terms of variable to the pressure. So this 3 point has the same pressure. Now when you blow air in between those two papers, what will happen? As we demonstrate in the class, when we blow the air in between this paper, the paper will come closer to each other. Wow, how does this mean? So what happened actually? When this air is blowing in between the paper, the velocity of the air increases, so the pressure decreases. Well, as you know that outside this paper there is no change in pressure, the pressure stays the same, while in the middle the pressure is decreasing, so there is pressure differences that causing a force act on these two sides of paper, pushing the paper close to each other. So from this example, we know that when we increase the velocity of the fluid, the pressure decreases. Well, that is the phenomena, and we can explain it in words. But how if we want to explain it, if we want to prove it by mathematical term? So here I have a pipe. It has different cross-sectional area at each end, and it also has different height. So here is the end of a pipe that has smaller area, and at another end there is a pipe with larger area. So in this case, if we fill this pipe with water, the water will flow to the left naturally, but we will apply some force at the end of this pipe on the left, so it moves to the right as far as delta x1. So it will create velocity of v1. Now, well, at another end, actually there will be a natural force that is pushing back, and it will be changing its distance from this to this, delta x2. So let me draw another line. For example, this pipe is locating at some height to the ground. Let's say the lower pipe has height 1, this one is having height 2. Right. So I'm going to explain this with conservation of energy. In the left pipe, first one acting to the water, pushing it as far as delta x1. So there will be work done in this part, and it has velocity, that means it has kinetic energy, and it is located at some height to the ground, so it also have potential energy. Next, at the second one, there is a force acting here, but the distance traveled is to the right, so there will be also the work done here, added by kinetic energy because it is still moving, and there is also potential energy. So the work done by the force is the force times the displacement. So F1 times delta x1 added by kinetic energy, a half mv1 squared added by mgh1 equal to F2 times delta x2 added by a half mv2 squared added by mgh2. Well, we can substitute mass with volume times density, and we can also substitute force with area times pressure, or vice versa. So this force P1 times A1 times delta x1 added by a half V rho V1 squared added by V rho GH1 equal to P2 A2 delta x2 added by a half V rho V1 squared, V2 squared added by V rho GH2. Well, as you know that volume of the water in position 1 and 2 will have the same amount, so volume is area times its height, bottom area. So this one is actually volume, this one is also volume, so we can cancel volume because it is contained in all the part of this equation. So what are we left? We are left with this big equation. P1 added by a half density velocity 1 squared added by h1 d8 equal to P2 a half density times velocity squared added by h2 dg. Well, that means this part, because condition 1 equal to condition 2, that means it is in a constant value. What does this mean? So let's say that the height are the same and when the velocity increases, there should be another value decreases. So instead of density, the value that will be decreases is the pressure. So that's why, as mathematical term, we can say that if there is a change in velocity, there will be a change in pressure. The increasing of velocity of the fluid will be decreasing the pressure at that point of the fluid. Well, here another example. This one is same as a paper demonstration that we done before, and here is the perfume sprayer. Actually, there is a pipe here submerged inside a perfume, and there is a pump of air. When the air is being pumped to the top of this pipe, it will create low pressure at here. So the perfume will flow from bottom up. It will goes from high pressure to the low pressure. Another example is chimney. Here, chimney is built so high, so when the wind is blowing at the top of that chimney, it will create a low pressure of air, and the smoke that comes from the bottom, which is high pressure, will be flowing out upward. Here is another example of this principle. Here is a picture of an aeroplane, and if we cut the wing will be shaped like this picture. So there will be some sort of bulge or flat at the bottom, but there will be a bulge at the top. So here, let's say if the wind or if the air flowing through the wings like this picture, the velocity at the top will be higher because the distance traveled by the air will be also longer. In that case, the velocity here becomes greater, so the pressure will become lower, as shown with this little arrow. While at the bottom, the velocity is lower, so the pressure will be bigger. So it is shown by this bigger arrow. So there will be, if you subtract the pressure at the bottom and the top, and there will be a remaining pressure that is causing the aeroplane to fly, and this is called the lifting force. Okay guys, that's all for this episode. I hope you enjoyed this video. I hope you learned something. I hope you write down all the things from this video. See you guys. Bye bye.